Alright, what's up guys? Welcome to another C++ tutorial. Today we're going to be going over if statements, switch statements, and some relational operators. So, ifs and switches allow you to dictate the control flow of your program. They allow you to execute certain parts of code in certain cases. So let's start with ifs. Simply put, the easiest way I could say this is that an if statement says, if something is true, then do this. It's like an if-then clause. So the way we write an if statement, we use the keyword if, followed by parentheses. And in these two parentheses, we're going to have our condition. And this condition is always evaluated through, Boolean logic, if it's true or false. So if the statement's true, do this. If it's false, don't do it. Just skip the statement. So when you write an if statement, you're going to have a condition. I'm going to throw me an error here because these things don't exist in my code yet, but this is just for some placeholders. If I have a condition, and if it's true, then execute this line of code. And I could just write something like Hello World. So if I give this if statement a statement that's true, it's going to execute this line of code. And one thing to note is when you have if statements, it always executes the line of code right after it. After that, it's done. So it's going to control to a normal flow in your program. So if I had something like cout back to normal, so the normal part of the program, no cases that we're going through. Okay. And like I said, these conditions are evaluated for truth. So for now, I can just pass it true. You'll see that it's gonna see out Hello World and back to normal, because first we're going to the statement. The statement's true, so it's gonna execute the next line of code, which says Hello World. After that's done, remember it's gonna return back to the normal flow of the program and execute this line of code, because it's outside the if statement. So let's see, if I run this, you should see that it's going to display these two lines. So that worked, right? And let me show you if I did false, because again, if statements always evaluate on truth. So now that this is false, it's no longer going to execute this line of code that says Hello World. So all you're going to see is back to normal, because the logic of the program now is that the case is false, so don't execute this line of code. It's just going to execute this line of code, which is the normal flow of the program. So if I run it again, you'll see that it only displays back to normal. So that's just one example. Now, to get more specific, you can do more specific things like, say you had some logic in your code, right? And you have this variable that you got input from. I'm not going to get input from the user, but we can just set it up and hard code it. If I had like an integer, we can just name it x, and I set it to 1. Alright, so we know that x is equal to 1, and in my condition, this is where we're going to start using the relational operators. So these operators are what you're going to use to compare things. It's like the same thing as saying x is equal to this, or x is greater than, x is less than, and vice versa. Usually, I can type it out here for you. You have operators like this. Let's see, greater than, less than, oops, it's supposed to be a comma. Greater than, less than, greater than or equal to, so you have the alligator plus the equal sign. Likewise, ooh, my voice cracked, the hell. Less than or equal to, right? You have things like and. So it's going to evaluate on both sides of this operator if x is blah 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 and if x is blah blah blah. Those two statements have to be true. If you want to do or, use these two lines here. It's going to say if x is equal to whatever, or if x is equal to whatever. Only one of those statements have to be true. in order for the condition to be met. So I'll show you an example of each and every one. So we know that x is equal to 1, right? So if x, we'll use this sign. If x is greater than 0, which it is, it's 1, this line of code should be executed. Hello world. I'm just going to run it. And you'll see that it gives me that statement, hello world. The if condition was met, and it's working properly. And then again, we're back in the normal flow of the program. It says back to normal, because this statement is outside the if. It's not controlled by that condition. Okay. I could say if, another example, if x is greater than or equal to 1. Again, this is true. So that should give me hello world and back to normal, and it did. Oops, you can see it right here. It did, so that's good. Let me show you a false statement. If x is, if it's less than 1. So x is equal to 1, but it's not less than 1. Oh, you know what? I forgot to add the equals operator. I guess I could show you it here first. So if x is equal to 1, if x is equal to 1, then see out hello world. And it worked again. You know, another thing I just realized, I forgot another operator, there's so many, is not equal to. So you denote that using the exclamation point and equal sign together. This is x is not equal to 1. So if x is not equal to 1, see out hello world. But remember, x is equal to 1, so this should return false, and hello world should not be displayed to the user. Instead, it'll just say back to normal. And it worked, right? Because it's false. If x is not equal to 1, display hello world, but x is equal to 1, so that statement is false. And so now all we get is back to normal, since it's in the normal flow of the program. It's not dictated by this if statement. Another thing, for conventionality's sake and readability, you always want to indent your statements that follow the if. This just makes it look easier to say that this line of code it belongs to this if statement. Another thing to mention is that you can carry out multiple lines of code after a statement, a conditional statement. And to do that, you use these curly brackets. Right? So anything that falls within these brackets after this if statement will be executed. So I can have another statement, say, to show you that it's part of the if statement. I'm part of the if statement. End line. Okay, so what are we evaluating here? If x is not equal to 1, but x is equal to 1, so none of these lines of code are going to be evaluated because it's false, because x equals 1, right? So it's back to normal. But if I say x is equal to 1, if x is equal to 1, then see out these two lines of code. This should be true. NANI? Oh, what the heck? Oh, what the heck? Do this. Okay, that was really weird. I don't know what happened there, but I guess the program was just being all janky. But you'll see here that I executed multiple lines of code from the if statement, right? Because x is equal to 1, so it's true. It says hello world, I'm part of the if statement. After this, we go back to the normal flow. It says I'm back to normal. So that's good. Did it. Let me show you these other operators here. The ands and ors are really important. So if I say and, or sorry, to further illustrate this, let me just make another integer variable. If x is equal to 2, okay, not if, sorry, x is equal to 2. We're declaring and initializing it, but in my if statement I can do something like if x is equal to 1 and if x is equal to 2. And then evaluate these two. So both of these statements have to be true, that x is equal to 1 and x is equal to 2. Oops, sorry, you know what? That's not going to work because I'm overriding x is equal to 1 right here. So let's make this y. And that's better. Sorry, I'm a trash coder, guys. Let me run this. So that should evaluate because both parts are true. X is equal to 1, y is equal to 2, and you'll see here in the output it says hello world. I'm part of the if statement. And now I'm back to normal. And you'll see here that I can show you what happens if it's false. So we're going to set y, if we're going to check if y is equal to 3, the second part of the if statement. And it's false, right? Because y is actually equal to 2, but we're checking if y is equal to 3. So what we're asking is if x is equal to 1 and if y is equal to 3, then do this. But remember, x is equal to 1, so that's right. But y is actually equal to 2. So this is false. Okay? Because remember, in an and comparison, both sides of the operator have to be true. So let's just do this, right? And you'll see that this is false, and the flow of the program is back to normal. It's at the normal flow because none of this gets executed because the if statement is false. Let me show you guys the OR operator. Oops, there we go. Right, so we use the two lines to denote OR. So now we're checking if x is equal to 1 or if y is equal to 3. So only one of these sides have to be true in order to get this statement to execute. Okay, so this should work because x equals 1, y isn't equal to 2, or no, y is equal to 2, but it's not equal to 3. But that's okay because x is equal to 1, so this statement is still gonna execute. Why is this not working? Let me do it again. Here we go. So you'll see that it's true. Hello world, I'm part of the if statement, back to normal. If I said something like, let's see, x is equal to 1, right? I'm gonna make this statement false now. I'm gonna check for if x is equal to 2. I'm gonna run this. This shouldn't work because both sides are false now. And if you can see here in the terminal, it says back to normal. And it skips the if statement. So that is good. Another thing with if statements is you can have multiple if statements stacked on top of each other. Like this. So you can have an if, then the condition, then you can do else, if, let's make another variable here and make this easier. Let's have z. This z is equal to 3. So let's check if else if z is equal to 3, and do cout and say z is 3. So let's see, if x is equal to 2, else if. So actually this, I don't think this is gonna be outputted, because if you do an if statement like this, else if, this else if is connected to this if statement, if that makes sense. So it's gonna check for the first statement that's true, and if it encounters a statement that's true, then it exits this whole thing. And so are any of these true right here? X is equal to 2. It's not. It's actually equal to 1. Okay, same thing here. So let me make this true. X is 1. So this statement is true. This statement is also true, but this shouldn't execute because it's attached to this if statement. You're saying to do either one of these things, but you're only going to do the first thing that's true. Let me run this. Yeah. There you go. Hello world, I'm part of the if statement. So it only executed this. Oh, you know what? Hang on, boys and girls. Forgot an equal sign. See, this is a common mistake here. always want to check your operators and what your condition is. Sometimes you're going too fast, you code too fast, it messes up. So let's see this again. Yep, still works. I called it. I'm still pro. Hello world, I'm part of the if statement. Okay, so you'll see that z is equal to 3, and it is. This is a true statement, but you're saying else. If this was false, then check if this is true. But this statement up here wasn't false. It's true. So it's going to execute the first true statement, and then it's going to exit this whole if-else statement if it encounters the first true statement. So one way to combat that is you could either do like you could say or if z is equal to 3 up here, because now you're checking in here in one if statement if any of these three are checking that these variables here are equal to these numbers, right? Another thing is, okay, yeah, so if you wanted to have this run on its own, say you wanted to do this and then just check regardless if z is equal to 3, then you can do it separately like this. You can just have two separate if statements. That's fine. But now let me show you switch statements. So it's a little different, but the syntax is different, but the fundamental concept is the same. So to make a switch statement, we're going to type in the keyword switch, followed by parentheses. And in the parentheses, we're going to use whatever data or variable that we're going to evaluate our cases by. So we can just use x in this case. And for reference, just remember that x is equal to 1. So following the switch statement, we're going to have some curly brackets here. This is our coding block. And in this block, we're going to have our list of cases. And so for example, we're going to have case 1. These case types, like this number is an integer. And remember, what we're evaluating is of type integer. So they have to be of the same type. Also, note that we're not really doing like an if statement where you see me comparing variables with each other, or relational operators, like if x is equal to 1, or if I'm checking if x is greater than 1. We don't really do that with switch cases. We evaluate these things by constant expression. So we know that this has some data, and we just evaluate if it matches our case. Okay? So for case 1, we can just say something like cout hello world and line. And for readability, I'm just going to tab these out here. There you go. Then you can have another case, case 2. Cout goodbye world and line. For case 3, we can do something like cout end world and line. And so if I run this, what this is gonna do is we're gonna have to go through the switch case. Now switch takes x, which is number 1, the integer 1. So it's gonna go to case 1 first. It's gonna say hello world. So you're gonna notice here that it says hello world, but it also says goodbye world, and then end world, and then of course our normal flow logic here. That doesn't matter. But notice it executes all 3 cases. Okay? So that's important, because you can think of all these cases like a waterfall. Whichever statement gets executed first, which in this case was case 1, the following cases will always be executed. So if I take this switch and evaluate it for y, we know that y is equal to 2, so it's going to start at case 2 first. That means it's going to evaluate goodbye world and end world. It's going to execute these 2 lines of code. So I'm going to run it here. Oops, wait. Let me do it without X, debug, start without debugging. Here we go. Okay, you'll see here it says goodbye world and end world, and back to normal, which is the normal flow control. So you'll see that these 2 statements got executed, case 2 and 3, because y is equal to 2. So it goes to case 2 first, and then it's going to execute goodbye world, and then it's going to cascade into case 3 and execute that. So to stop this from happening, we use breaks in our switch statements. So what that's going to do is it's going to say, hey, if I'm in case 1, do this, but then break here and exit the switch statement. So I can just add these to every line of code here to make sure that I only want to execute these cases. Space this out here and make it easier to read. And so what are we evaluating here? We're evaluating for y, so it's going to go to case 2. And we have the break statement, so it's only going to execute goodbye world. After that's done, it's going to break, and it's going to exit the whole switch statement and return to the normal flow of the program, and it's going to see out back to normal. So if I run this again, oh man, why do I get this janky stuff, man? Hang on, guys. Let me just, rebuild solution. Start. Okay, here we go. So you'll see what I said is true. It said goodbye world because y is equal to 2. It's going to go to case 2 first, and then execute goodbye world. But then we have the break statement, so it breaks out of the switch and goes back to the normal flow of the program, and it says back to normal. So that is pretty much it with the switch statements and if statements. Oh, you know what? There's one more thing actually. So in the case that any of these cases don't get evaluated, so if y isn't equal to 2, if it's not equal to 1, if it's not equal to 3, or whatever cases, you can have a default case that gets executed. We use that by using the keyword default. And this statement only gets executed if none of these cases are true. Okay? You can do whatever you want again. You can say cout. You can say default. Just gonna show we're using the default case. And in the default case, you don't have to use a break statement. It always goes last, usually. To be safe, you could use break. That is one safe convention you could do. I won't use it here just to show you, but you can do it. You probably should do it just in case. But you'll see that this is not going to be executed because y is equal to 2. So it's going to go to case 2 and break out the switch statement. So if I just run this, why does this happen, man? Can I clean my solution? Debug again. Here we go. Okay, so it said goodbye world, case 2, right? Because y is equal to 2. And we have our breaks. Nothing gets executed, not even the default. But now if I say, let's see, let's make y equal to 5. Okay. Remember, none of these cases have 5 in it. So that means none of these cases will be run, except the default case, because the default case only runs if none of these cases are ran. So let's run it. Alright, that's cool, dude. Start without debugging. There you go, bro. Default. So remember, we made y equal to 5. The switch statement checks if y is 5, and it goes in the switch, checks for a case that's equal to 5. It's not case 1, not case 2, not case 3. There's no case 5 here. But wait, there's a default statement. Okay? None of these statements are equal to 5. So we execute the default statement, and it says cout default end line, and it says default. And then it returns to the normal flow of the program, says back to normal, and that's it. So that's pretty much it for switch statements and if statements in general. Some relational operators. You're gonna be you're gonna be using those a lot when you advance in your programming. It's very important when you go on to make apps and stuff, to have a good flow control, and you'll use it to execute certain cases and check for edge cases, like if something is true, or you might have one particular case where if this happens, then you gotta run something, and that you always have to check for it. Like if you're checking for something that's empty or something that's false, then it's very important that you have these cases, because if you don't have a case like that to check a corner case or an edge case, whatever you want to say, that can break your entire program. So having these statements helps you catch those errors and have you control the flow of your program so that it works. So I think that's it. Yeah, peace out.